gradient and directional derivative using the gradient of the function f of xy. So this upside down delta that represents gradient, we call this like del of f. So this upside down triangle, we don't call this delta, we call this L, del, del. So the del f of xy to find a directional derivative. So here is the given. Find the directional derivative of the function f of xy equals to 3x squared minus 2y squared. So that looks like a three-dimensional hyperbola to me. And then at this point, negative 3 over 4, that is the x coordinate. The y coordinate is 0 in the direction from point P to point Q. So the very first step is we have to start at point P to point Q is we would like to find a vector from P to Q, then make it a unit vector. Then make it a unit vector. Okay, so what is a vector PQ? So vector PQ, that is equals to, we will take this coordinate minus that coordinate, so that will be a 0 minus negative 3 over 4, and then vector I plus 1 minus 0, 1 minus 0, and then times vector J. So that is a 3 over 4 vector I plus 1 times vector J. Okay, and this is clearly not a unit vector. Why? Because if you check the magnitude, the square of negative 3 over 4 plus 1 square, that is not equal to 1. So since the magnitude, the length is not equal to 1, then the PQ is not a unit vector. How do you make a unit vector? The question is simple. So let's say I give you a number, a 6. 6 is not equals to 1. How do you make 6 equals to 1? The answer is you simply have to take 6 divided by 6, that is equals to 1. So same thing in terms of vector. So the vector u, a unit vector, that is equals to vector PQ divided by its magnitude. PQ, the magnitude. So PQ is 3 over 4i plus 1j divided by the magnitude of that. That is the square root of negative 3 over 4. I wrote 3 over 4, huh? This is supposed to be a positive 3 over 4. This is supposed to be a positive 3 over 4. And then plus 1 square. So that is a 3 over 4i plus j. Let's not skip any steps. So that will be like 5 over 4. 5 over 4. And then you 3 over 4 times 5 over 4, that is the 4 is cancelled, so this is a 3 over 5i, and then plus 4 over 5j, and now this is a unit vector. How do I know? Because the square root of 3 over 5 square plus 4 over 5 square, you can check the math real quick, that is equals to 1. Okay, so what is the next step? The next step is if we will go ahead to find the gradient. So what is the gradient formula? The gradient formula is we have a del f. So the gradient of the function is equals to the partial derivative of the function with respect to x times vector I plus the partial derivative of the function with respect to y times vector j. And then the partial derivative, what's the partial derivative? The function is right over here, right? So the partial derivative, x is a variable, the first term will be a 6x, and then the 2y is just a constant, then minus a 0. And then with respect to y, 3x squared will be a 0. For the negative minus 2y squared, you bring the 2 down, and then y is just y. You bring the 2 down, and then just a 4y, just a simple power rule. All right, so this will be a 6x times vector I, and then plus, not plus, minus. It's a, yes, it's a minus because this is a minus, and then minus 4y times vector j. All right, so how about the gradient at that point? So we are looking for the gradient at the given point. So at point P, which is x is negative 3 over 4, y is 0. So the gradient is del f of negative 3 over 4, y is equals to 0. So you simply plug in the x and y. So that one is going to be 6 times negative 3 over 4 times vector I, and then minus 4 times 0 times vector j. So therefore, this is equals to negative 9 over 2 vector I, and then minus, let's keep the 0, and then times vector j. And then how about the directional derivative? The directional derivative, we will be using the alternative form, which has a dot product. So let me give you the full name. The directional derivative. That will be the directional derivative of vector u of f of xy. So that is equals to the gradient of the function, and then here is a dot product. So this one is a dot product, and then you do the dot product, and then the unit vector u. So this is a dot product. So dot product. All right. So which is D stands for directional derivative of the vector function f of xy, x comma y. That is equals to, so we will bring the gradient down. So that will be what we just got. Then that will be a negative 9 over 2 times vector I minus 0 times vector j. And then we do a dot product, 3 over 5i plus 4 over 5j. And then how do we do the dot product? To do the dot product, so that will be this times that. We only multiply the fractions. So negative 9 over 2 multiply 3 over 5. And then the dot product is a plus. And then the 0 times the 4 over 9. So 0 times 4 over 9. So that is equals to negative 27 divided by 10. So this is the directional derivative. At the point negative 3 over 4 comma 0. Okay, the next thing that I would like to do basically right now, we just fully answered the question. So next thing that I would like to do is, how about we go over this all over again using a picture. So let me lead you to the next page. The next page, I prepare a picture. So what is the graph represent? Let me switch to a different color. So the graph is a surface. So this surface is represented by f of xy equals to 3x squared minus 2y squared. It's like a three-dimensional hyperbola. And then there is a point at P. So do you see the P? So a point P that is negative 3 over 4 comma 0. And then the Q is a 0 comma 1. And then this is on the y-axis. And then this is on the x-axis. And then PQ is a vector. So the vector PQ is an arrow. Okay, what is next? So this point, negative 3 over 4 comma 0, corresponds to a point on the domain. So that is a point on the domain of the function, which is a point right here. So that point is within the domain. And then what happens when you plug in this point to the function? So let's say f of x equals to negative 3 over 4, y equals to 0, and then you have 3 times negative 3 over 4 square minus 2 times 0 square. That is equals to 27 over 16. So this is a point, the x, y, and z. This is a point on the plane, on this plane, this pink plane. So negative 3 over 4, y is equals to 0, 27 over 16. So at this point, I gave you the surface which is a three-dimensional hyperbola, and then I gave you a point P and then a point Q. From point P to point Q, there is a derivative. There is not a derivative. This is a vector from point P to point Q. P has its coordinate, Q has its coordinate, and then the point P is a point on the domain of F. do you still remember the way you sketch the graph of a three-dimensional plane? So you start with the domain, right? So you get a function f of xy equals to some x and y, right? And then you find the domain. So either the domain is like a circle, the domain is an ellipse, and then you find the range of z, and then you just make the ellipse or the circle three-dimensional. Same thing right here. I started with a point. So this point is on the domain. The best way to picture the domain is like the paper that you are taking notes right now. So that paper, that piece of paper on the table is the domain. So on that paper, you have an x coordinate and a y coordinate. So therefore, you have a point on paper. So once you plug in that point to the function f of xy, you obtain a z coordinate. And then you can look up, so this is a point. Once you do the plug-in and then you look up, well, after you plug in x and y, this is a point on the plane, on this surface. On this surface is no longer on the xy plane. So this point P, negative 3 over 4 comma 0, and the point Q is on the xy plane. Do you see this? Xy plane is like the piece of paper that you're writing on right now. Once you plug it in, once you plug in a P to the function and you get a point, this point is on the surface, right? It's on the surface. So we are looking for the slope of this point. And then since this is on the surface, it's three-dimensional, you have to tell me a direction. So in math, what gives you direction? Vector. So that's why we need a vector. And then moving on, P is a point on the domain of F. And then what about the gradient? What about this gradient? So this gradient F when P is equals to negative 3 over 4 comma 0, so you have a negative 9 over 2i plus a 0j, and then the slope that we got is negative 27 over 10. So at this point, if you are going to this direction, the slope is equals to negative 27 over 10. And then don't forget that the gradient, which is right here, is a vector value function. The gradient is a vector value function. So it tells you where to go. If you want to go to that specific direction, the slope is equals to negative 27 over 10. All right, so that will be all in this video. In the next problem, I would like to put three independent variables in the function. So that will be f of x comma y comma z. So you will see three independent variables in the function. All right, I will see you all in the next one.